A coil is rotated steadily between the poles of a magnet. The coil is connected to oscilloscope. Which diagram shows a voltage against the time graph for AC generator? So A is the right answer for this. Question 36. The diagram shows a lamp connected to a transformer. What is the potential across the lamp? Means output voltage. You can clearly identify this is a step up transformer because so it cannot be 2.412. So higher voltage will be there. You have the formula. This one is NS, NP, VP, and VS. So VS over VP is equals to NS over NP. So Vs we don't know. Ns is equals to 200. So 200 divided by 40, which will be equal to 5, and 5 multiplied by 12, that's equal to 60. Question 27. Which line in the table shows whether iron and steel are ferrous and non-ferrous? Ferrous means magnetic and non-ferrous means non-magnetic. Which line correctly describe their nature for iron and steel? Iron is a magnetic material. Steel is also a magnet. Iron, nickel, cobalt, steel. These all are magnetic material. Means steel is also a magnetic. The term ferrous means magnetic. So both are ferrous or magnetic material. Iron, steel, nickel, cobalt. These are all magnetic. A solenoid carrying a current is used to demagnetize a bar magnet. This is a method of demagnetization. The methods of demagnetization is by passing an alternating current and remove the magnet out. A DC is used to magnetize a material and AC is used to demagnetize. So alternating current and slowly through a solenoid. So it will be demagnetized. The three methods of demagnetization: heating, hammering, and passing alternating current in a solenoid which produce a magnetic field of its own and gradually take it out or slowly take it out from the magnetic field. The wire XY shown in the diagram is connected to a sensitive voltmeter with a zero center or center zero. X and Y is then moved quickly once through a magnetic field. What we will observe? Zero is at the center. Because we are moving in one way, so the current will produce only in one way. The needle move briefly in one direction and then return to center. The direction or the motion of the magnet or the wire decide the direction of induced current. Because we are moving only in one way, the induced current will be in one way. If we were vibrating this, like moving to and fro, then the needle will also deflect right and left. So when we move it quickly, means we move out from its magnetic field. So when we move out from its magnetic field, there is no change in the magnetic field. That's why the induced EMF will be zero. And when we are moving in a specific direction, current will move only in one way. If we vibrate the wire within the magnetic pole, then the current will produce in both directions. Question 35. A diagram shows a transformer connected to, so this is VP, NP, VS, we need NS. It's a step down, so these two cannot be an answer. The ratio of the voltage and the ratio of the turns is always same. Even if you don't want to, like, you can just work out the turn ratio with the voltage ratio should also be same as the turn ratio. So B is the right answer for this. Question 25. Iron is a magnetic material used to make temporary magnet. What could be the answer for question 25? So magnetic pole always induce magnetism occur. So if north is facing, that pole will be south and the other one will be north. So pole at P will be south and the pole at Q will be north. Question 26. An electromagnet is used to separate the magnetic materials from non-magnetic. Why is steel unsuitable as a core of electromagnet? Same question repeated. A temporary magnet should be made up of iron because steel form a permanent magnet, so it will not be suitable for the purpose. A wire is perpendicular to the page carrying a current out. So current is out. You're using a right hand grip rule. Your thumb should point out and your fingers will turn in the magnetic field using a right hand rule. Which compass shows the deflection direction of the magnetic field caused by the current? Your thumb should point towards you. Out means towards yourself and your fingers will turn around it. So which one is correctly shows? So your thumb point, right hand, the thumb point in the direction of current and fingers will turn around. So when you use the right hand, this is how your magnetic field will appear. So which one is showing a correct answer? C is showing the correct answer. What about 35? Question 35. The transformer has, this is NP 50, NS is 100. This is again a repeated question. So VP, you need Vs. So turn ratio is two times. The voltage should also be twice. That's why B is the right answer. So these are some questions related to magnetism. Next session, I will discuss block 5, the atomic physics. Any question related to the class today? Any question or a doubt related to the class? Okay, so the previous question, the previous question is a wire perpendicular to the page carry a current, electric current in a direction out of the page. So if it's carrying a current out of the page, how to find the direction of a magnetic field? You will use the right hand grip rule. According to right hand grip rule, your thumb, if it's a straight wire, a wire is there, the thumb will represent in the direction of the current. So that in this example, your thumb should point out and your fingers will turn in the direction of a magnetic field. So when your thumb is pointing out of the screen and fingers turned around it, so how the direction of a magnetic field will appear? It will appear in this manner. So which compass needle is showing a correct direction? So C is showing the correct direction of magnetic field, like same as a magnetic field. So I'll end the session and share this with you.